This video is on parallel and perpendicular lines. We will be writing the equation of lines that are parallel or perpendicular to given lines and going through given coordinates algebraically without the use of graphing. So we're going to write the equation of the line that is parallel to y equals negative 2x plus 1, but goes through the coordinate or point 2, 3. So when we look at the word parallel, we have to remember that parallel means they have the same slope but a different y-intercept. So right now, this equation is in slope-intercept form. We see that the original slope, the coefficient, is negative 2. So if we want the parallel slope, it'll be the same, which will be equal to negative 2 as well. We need to know what our new y-intercept is, because we cannot use the 1 again. So we need to use algebraically of y equals mx plus b. We are given the coordinate of 2, 3, which is the x and a y coordinate. So we can actually plug in our x, our y, and our new m into our equation to solve for b. Our y value is 3 equals the m value that we need to use is going to be negative 2 times our x value is 2, and we need to find the b value because we do not know the y-intercept. So we need to simplify. This will be 3 equals negative 2 times 2 is negative 4 plus b. We add the 4 to both sides and we get 7 is equal to b. So our new y-intercept is 0, 7. Now that we have the parallel slope and our new y-intercept, we can write our equation. So our equation is y equals, the equation that is parallel to the original, going through the coordinate 2, 3, is y equals negative 2x plus 7. So our slope, our parallel slope, and our new y-intercept. This is the equation that is parallel to y equals negative 2x plus 1, but it goes through the coordinate 2, 3. So we can do algebraically perpendicular as well. Write the equation of the line that is perpendicular to y equals 4x minus 5, but goes through the point 8, 5. So first, we need to know our original slope. The coefficient was 4. So our perpendicular slope, so I'm going to put perpendicular slope, m perpendicular, will be the opposite, so that'll be negative. And the reciprocal of 4 is 1 over 4. So this is our new slope we need to use. We need to use that slope to help us find our new y-intercept. So again, we're going to use y equals mx plus b. We have the coordinate 8, 5, which is our x and our y, so we can plug that into our equation. Y is the 5 equals our slope that we need to use is the negative 1/4, not the 4. We need the negative 1/4 because that's our new slope times the x value of 8 and then plus b because we do not know our b value. Let's simplify. We have 5 equals negative 1/4 times 8 becomes negative 8 over 4, which is negative 2 plus b. Add 2 to both sides. We get b is equal to 7 again. It's just a coincidence. Our new y-intercept is at coordinate 0, 7. We have our new slope and our new y-intercept. Let's write our equation. So the equation that is perpendicular to y equals 4x minus 5, going through the coordinate 8, 5, is y equals negative 1/4 x plus 7. This equation is perpendicular based off of the slopes, and it goes through the coordinate 8, 5. We did this algebraically. In a different video, I showed how to find the equation graphically by plotting the given point and using the slope to follow the pattern to find the new y-intercept. This is done these problems right here are done without the use of a graph. This next problem asks us to write the equation of the line that A contains the point and is parallel to the given line, then B contains the point and is perpendicular to the given line, and then C, graph all three lines, the original, parallel, and perpendicular, on the same coordinate plane. So we need to take this equation, x minus 1/3 y equals 4, and we need to put it into slope-intercept form so we can easily find the slope and the y-intercept. So we're given this line, and we're also given this coordinate. So the first step is to find the original. So the original. Put this into slope-intercept form. X minus 1/3 y equals 4. We need to subtract the x to the other side. So we'll have negative 1/3 y equals 4 minus x. Because we're moving x to the other side, we subtract it. Then we need to multiply by the reciprocal, not opposite, but the reciprocal of negative 1/3. So we're going to multiply both sides, all of it, by the reciprocal of negative 1/3. So we're going to multiply by negative, got it, because we're multiplying by the negative. Reciprocal of 1/3 is 3/1. So we'll multiply by negative 3/1. Because a negative 3 times a negative times a negative is a positive. And then we'll have 3 divided by 3. That gives us the positive 1y. Equals, we're going to multiply by the negative 3 to everything. So negative 3 times 4 is negative 12. Negative 3 times negative x is a positive 3x. So our original equation is y equals negative 12 plus 3x. Or we can write it out as y equals positive 3x minus 12. Either one will show you your original slope and your original y-intercept. So now that we have our original, we can see what our slope is, and then we can find the parallel and perpendicular aspect. So part A. Part A asks us to find the equation that contains this point and is parallel to this line. We have, for the original line, we have the slope of 3. So our parallel slope will equal to 3 because it has to be the same. Using y equals mx plus b, and we're going to use this coordinate, we can plug in our x and our y into y equals mx plus b. Y is negative 2 equals the slope we want to use is 3 times the x is negative 3 plus b. We have negative 2 equals 3 times negative 3 is negative 9 plus b. We want to add 9 to both sides. We get a positive 7. Again, just a coincidence. So our new y-intercept is 0, 7. That lets us know that we have the parallel line equation is y equals positive 3x plus 7 because we have the same slope, we have the new y-intercept. This is the parallel line equation. Part B asks us to write the equation that contains the point and is perpendicular to the line. So question B, we have the original slope again was 3, but the perpendicular slope will equal to the opposite reciprocal. So opposite will be negative. Reciprocal of 3 is 1/3. That is our new slope. We want to find the y-intercept, the new y-intercept, by using y equals mx plus b and plugging in that same coordinate from earlier. The coordinate was negative 3, negative 2. Our y is negative 2 equals the new slope we want to use is negative 1/3 times our x value is negative 3 plus b. we have negative 2 equals, so a negative times negative is a positive, 1/3 times 3, so that will become 3 divided by 3 is 1 plus b. We want to subtract 1 from both sides, so we will have negative 3 equals b. That's our new y-intercept, or that's the constant. So our y-intercept is now 0, negative 3. Our perpendicular line equation is y equals, our new slope is negative 1/3 x, then our constant is minus 3. This is the equation of our perpendicular line. We now have all three equations, so we can graph all three on our coordinate plane. We need to have our x and our y, and we can probably count by ones, even though this goes down to negative 12. We can go off the graph just a little bit. So we'll count by ones. So our original, let's graph our original. Our y-intercept is at 0, negative 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down here, 11, 12. And then our slope is 3. So 1, 2, 3, 1. Change in y over change in x. Change in y over change in x. This is our original graph. So this is y equals 3x minus 12. This is the original. We have the parallel line, which is 3x plus 7. So our first coordinate is 0, 7. Right here. 3x, 2, 3, rise 3, run 1. So change in y over change in x. And then we can go negative 3 over negative 1. Connect those. This is y equals 3x plus 7. This is the parallel line. Then you can see that these lines will never cross. Then we'll have the perpendicular line. The first coordinate is 0, negative 3. And our slope is negative 1 over 3, so change in y of negative 1, change in x of positive 3. And then we can also go change in y of positive 1, change in x of negative 3. And we'll connect this. And if you notice, this line is perpendicular to both of our lines, the original and A, because the original and A have parallel slopes. So if I am perpendicular to one line, it has to be perpendicular to the other as well. This is y equals negative 1/3 x minus 3. This is the perpendicular line. Couldn't fit it in there. It's the perpendicular line. And that is how we can do this algebraically. We could have done it with the graph as well, but showing how to do it algebraically is helpful if your y-intercept is not a nice, clean integer.